Hi, welcome to our next complex numbers video. This video is about solving rational equations. Now, a rational number is a number that can be written as a fraction. For example, 2/3 is already a fraction, but the number 5 can be written as a fraction, like 5/1. Numbers that cannot be written as a fraction are called irrational equations. And you've come across a couple of those before, pi, and you may have come across Euler's number E, and you've come across surds like the square root of 2. So basically, a rational equation is an equation that deals with fractions. Now, you've done rational equations before, but here are a couple more complicated examples that we can hopefully get you more confident with. Here's example 1. Solve the following equation. 3x plus 1 over 2x minus 4 is equal to x plus 3. Now, you may have ways to solve this that are different to mine, but I like to treat the right-hand side as a fraction by putting x plus 3 over 1. And whenever I see a fraction equal to a fraction, I like to use a method called cross multiply. I must have a over b equal to c over d for this to work. And what we do is we then go a times d is equal to b times c. So let me show you how this works in this example. We have a, which is 3x plus 1, over b, which is 2x minus 4, equal to c, which is x plus 1, over d, which is 1. So what we're going to do is we're going to go 3x plus 1 times 1, and that's going to be equal to 2x minus 4 times x plus 3. And I like to put each bit inside brackets. Okay, so now we're going to move on to solve it. To do that, we know 3x plus 1 times 1 is just 3x plus 1. And then we expand out the quadratic on the right and simplify this. 6x minus 4x makes 2x. Now, it's a quadratic, and I've got to get it all equal to 0. So it doesn't matter which side you move around, but I'm going to do the following. I'm going to subtract 1 off each side to get rid of the plus 1 on the left. And then I'm going to subtract 3x off both sides to get rid of my 3x on the left. And that gives me 0 on the left, equal to 2x squared minus 1x minus 13. And I know it's a quadratic. I like to put it the other way around, the 2x squared minus 1x minus 13 equal to 0. That's the way I prefer. And I've got it into the form where it's ax squared plus or minus bx plus or minus c equal to 0. Now I'm going to use the quadratic formula. There are other tricks you can use, factorizing and so on. But I know my calculator's got the quadratic formula set up ready to go. So I enter in a is 2, b is negative 1, and c is negative 13. And I can write down my two solutions. X is equal to 2.81 and also negative 2.31. And I've rounded both to 2 decimal places. Right, well, example 2 is pretty much the same as example 1. It's a bit more complicated. Solve the following equation. Notice we've got it in the form of a over b equal to c over d. Straight away we can go 5x minus 1 times the x minus 4. And that's going to be equal to the 2x plus 3 times the 3x minus 2. Now I've got to start expanding both sides. So expand the quadratic and expand the quadratic on both sides and simplify everything down as far as I can go. Now I've got to get everything over to one side and get it equal to 0. So again, it doesn't matter, but I'm going to get rid of the 5x squared on both sides to get rid of the 5x squared on the left. I'm now going to add 21x to both sides to get rid of the minus 21x. And finally, I'm going to take off the 4 to get rid of that and leave 0 on the left. Again, I prefer to write it as x squared plus 26x minus 10 equal to 0. I like the quadratic on the left and 0 on the right. I've got it into the form of ax squared plus or minus bx plus or minus c. So I grab my calculator, enter a is 1, b is 26, c is negative 10, and my two solutions are 0.38 and negative 26.38, rounded to 2 decimal places. Right, thanks for watching.